And we have seen that there is physical level definition. On top of that, we have the conceptual level definition and then the view level. I will say that physical level independence is achieved if changes in physical definition do not have any impact on application program. In the same manner, conceptual level independence is achieved if changes in conceptual definition do not have any impact on application program. Now we also discussed that this is achievable, but this is difficult to achieve. Later we will say that whenever we will be working with the DBMS, it provides an abstraction, and mostly we deal with logical or conceptual level definition. So, if the conceptual definition is remaining intact, unchanged, and if the underlying physical definition is changed, mostly it will have no impact on our application, as it provides an abstraction where we can deal with the logical definition. So that's why physical level independence is achievable. Rather, this one is difficult to achieve. Now, whenever we will be working with the database, so we need some language also. So to work with database, we will be requiring some language. Commercially, SQL is available to work with the databases. That is the structured query language. In the commercially available SQL, broadly we have two categories of statements, or generally we refer as languages also. One is the DDL, another is the DML category. So this part we refer as data definition language. This is the data manipulation language. So whenever we will be working with the, so basically this DDL, this is used to specify the schema of the database. Specify or modify. Now, whenever we are working with the DDL kind of statement, we'll see we'll be requiring a functional unit. We'll talk about the functional unit later. So this is to specify or modify the schema of the database. Suppose I want to create the student database where roll number is of type say integer, name is of type string, date of birth is of type day. So in order to specify this kind of schema, we'll be taking the help of DDL category of statement, data definition language. And DML is a data manipulation language. Now, this manipulation language suppose we want to insert data into the database, or we want to retrieve data, modify or delete the data. For these purposes, we need data manipulation language. Now, so somebody may think that, okay, I have the student database, so that's, if we assume that's a file, say there is a student file, try to remember the whole thing. Suppose we have created, we have considered a start record kind of thing. So extract rate kind of thing, say maybe the integer roll, say character name 31, etc., etc. So somebody may open up a binary file using a write, one can write, store the data into the file. So anyway, so that means one can go for manipulation. So if the data is into the file, then see, using any high level language, open the file, I want to retrieve a record. Read record, check whether this is the one that you want. So repeat this till end of file or record is found. So this is procedural. We have to specify the whole process. So this DML data manipulation language, it may be procedural or it may be non-procedural. If it is a procedural, along with what data is required, how to get it is also to be specified. Say I am looking for the details of a particular student. So you open the necessary file, read the record, check it, and repeat this process till end of file or the particular record is found. So whole process is has to be defined. That is the procedural. If the manipulation language is procedural, then all execution process is to be written. What I need and how to obtain. If it is non-procedural, only what is required has to be specified. Not how. We'll see that SQL provides, suppose from the student database, I want to find out the name of a particular student. Select name from which database, student, where roll equals to this. That's all. So obviously in the background also, in the disk, which block is containing, so read that particular disk block to the memory, check whether it is containing the record, go to the next block, etc., etc. See, these issues are to be handled by the database DBMS itself. So this is the thing that we will be dealing with, that is the non-procedural. So whenever we are comparing the SQL, the DML part of SQL as non-procedural, then keep in mind the context is that we are comparing with other end user programming language and DML. We are comparing these two. Try to remember this thing. The context is that we are comparing the DML with the conventional high-level languages with which so far we have programmed. This is I am mentioning because whenever we will be going for relational model, that time again from a different perspective, we have to understand procedural and non-procedural. So here the SQL is the end user tool. As programmer, I will be using SQL. So as programmer, I am using other high-level languages. Now compare in the same plane, in the same context, and try to understand from that context only. So this is the language part, and again, if we look into a special kind of user, that is DBA. Or before that, let us go for a core part of database, that is the database manager. Mind it, database manager is not the user. This is the software module forming the core part of DBMS. It performs lots of important tasks. It performs lots of important tasks. First thing is that interaction with file manager of operating system. See, database management system, it sits on top of our operating system. Now, why this is very important? See, database, it is stored in secondary storage. Obviously, database will be consisting of data will be stored into files. So this file management, it is the responsibility of OS, that is the file manager part of the OS that you have studied already. The file is consisting of so many disk blocks. So whenever accessing data, so basically interact with secondary storage, access the blocks, these blocks. If it is not present in our memory, it has to be read into the memory. If no space is there in the memory, no buffer, free buffer is available. So what will be the policies that you have studied in operating system also? Maybe that some part also was also discussed in the computer organization training. So see, which is that the secondary storage management, file management, these are the responsibility of the operating system. So on behalf of the database management system, this database manager interacts with database manager interacts with file manager, which is not part of the database management system, part of OS. File manager to work with data in disk. So that is one important task of this database manager. Then integrity enforcement. So somehow in our database we have said that that in our student database, say roll number, it has to be unique. Say there is name, date of birth, say score, say name has to be given, this is mandatory, it cannot be kept empty. Say score, it will be non-negative, etc. etc. So data must satisfy certain conditions. Or that we say constants. So now see, suppose we have in which department the student is studying. Say we have the valid list of the departments. Suppose we cannot have any department which is not present in the total list of the department. So that is an invalid department. So it must be present here in this list, in this database. Right? So there will be different kind of constants or conditions that data is supposed to satisfy. So whenever we will be adding the record into the student file, we'll have to check whether this roll number is already present or not. Or suppose we are trying to modify the department code. Say you have taken admission in a department, then in the spot round it has been changed, so you are modifying it. So modified value must be present there. Again, say interesting. Suppose I want to delete a department from this file, a particular record. Now, if some student is there corresponding to that department code, then see what will happen. Unfortunately, that student is becoming orphan. The department is not existing, but he or she is studying in that department. So whether that thing will be allowed or not, etc., what will be the policy? So the thing is that in my database, if the database is in a valid state, in a valid state of database, data must satisfy certain conditional constants. So whenever there is a change in the database instance, constraints are to be validated. So as programmer, if it becomes our responsibility, so whenever there is a change in the instance, we'll have to, whenever writing the program, we'll have to be careful what are the possible constants. Now we have to check. So at every point of our program, we have to take the responsibility to make a call to those validation functions. We see DBA database manager. This is the core part of DBMS. Database manager takes the responsibility of validating all specified constants. Whatever constants we have specified, it becomes the responsibility of the database manager to validate those things, to verify those things, whether those have been maintained or not. So enforcement of the integrity constant, that becomes the responsibility of database manager. Our role will be to specify those things. That's all. Then security enforcement. All data is not accessible by each and every user. So who can access what? And for what purpose? If I am creating a particular, say, student database, as owner of this, I can set the permissions that who else are allowed to work with this. Now, to work with this means I may allow somebody to see, somebody may be allowed to delete the things, somebody may allow. So what operations I will be allowing others, that also can be specified. So again, just like the constants, here also, once we have specified what other users can do with the database, our job is, our responsibility is over. Now, database manager will ensure that it goes according to that. So, this security is ensured by database manager as it is multi-user environment. So number of users are working with the database, but everybody cannot access anything or can do anything with the data. So that will be taken care of by the database manager. Backup and recovery. See, there may be failure. failure may occur. If it is not handled properly, the database may enter into an invalid state. Suppose the very popular example, suppose we have account number and balance. Say from account A to B, there is a transfer of say 10,000 rupees. Then its balance to be decremented by 10,000. This balance has to be incremented by 10,000. So suppose this was done, then there is a or off. So bank is the gainer. Bank is the gainer. 10,000 rupees without making the expense of putting it to the other account, bank will shut off its responsibility of this 10,000 rupees. This account is decremented, but this is yet to be incremented. So see, what is the valid state? Either none of the things will be happening, neither the decrement, not the increment. That's the old valid state. That is the old valid state. Or it will complete both the operations, then it will go to a new valid state. If it is half done, then it's invalid state. So whenever some transaction, some activity is going on, it is to be ensured that even if there is a failure kind of scenario, the database has to be maintained the valid state. Either it will be remaining into the old valid state, then we will be redoing the operation, or it will go to the new valid state. So failure may occur. There may be various types of failure due to program logical error or something else. Lots of issues will come up, or out of kind of extreme situation that may occur. So once the failure may occur, so it has to be recovered to ensure that database remains in valid state. So that is also the responsibility of database manager. As user, we are doing nothing, but we look into how it carries out. One very popular scheme is log-based recovery. That we'll see towards the end of this particular course. So anyway, that is the responsibility of database manager. Another important issue that we mentioned earlier, that which are the disadvantages for file processing based system kind of scenario, that is the concurrency control. That is also the responsibility of database manager. We know the meaning of the concurrency control, concurrent situation. We know some aspects of the concurrency problem, that racing problem kind of thing. So as and when required, it has to be serialized. That part is also taken care of by the database manager. So see, this is the forming the core part of the database management system, taking lots of responsibilities, starting from interaction with the database. Now rest of the things from the programmer's perspective, that is that integrity, validation checking, that enforcement, proper access of data, use of data, that is the security aspects, that is taken care of by database manager, backup recovery issues, and the concurrency control aspect. We have different category of user, particularly one particular type of user we must be aware, that is DBA. Database manager is the software model, not any user. DBA, this is a category of user. This is the human being. Database administrator. So database administrator, okay, administrator can play the role of some other kind of lower category of user also, but as DBA, has certain special privilege, can do this thing. See, overall schema definition or its modification. That is the responsibility of DBA. Now somebody may make a query that as we are talking about, I am creating the student database, etc., etc. Then if the schema definition becomes the responsibility of DBA, then how I will be creating the student? Pertinent issue. So to differentiate, I have used the term overall schema definition.
Sir.
Yes.
Sir, screen একদম বোঝা যাচ্ছে না স্যার। স্ক্রিনটা স্যার ক্লিয়ারলি বোঝা যাচ্ছে না।
Have you looked into the video?
No, sir.
The video link that I have sent yesterday, have you looked into that?
Yes, sir.
Was it visible there? Have you gone through the video that was sent yesterday or day before yesterday?
Yes, sir.
Was the visible there?
Yes, sir.
Then this one will also be visible.
Okay, sir. Okay, sir.
Right at this point of time, whether this is visible or not, it depends on lots of issues. One is the bandwidth issue, either of the two ends, this end and your end, and the device in which you are looking into. If you are looking into the screen through your mobile devices, possibly nothing will be visible. That I agree. So, like you, I am also helpless. So if you look into the video, if it is visible there, then it's fine. For the time being, it may not be visible or that much prominent right now. Okay. But I understand that some problem occurs. So anyway, so as user, I will create the student database, department database, etc., etc. So whenever I am saying that schema definition, then how will be defining the schema? So just to make it distinct, I have said overall schema definition. If we look into the Oracle perspective, see, as user in Oracle, I will be creating all these things. Okay. When I am saying overall schema definition, in Oracle, DBA will specify what are the files where the database will be stored. So if we take the word schema philosophically, I or a normal user at the conceptual level specifying the schema, but actually in secondary storage where it will be stored, those policies cannot be specified by a normal user. DBA for the overall database, that kind of features can be specified by the DBA. So that's why I have said overall schema definition, that is the responsibility of database management and database administrator. Then say in the same tune, say storage structure and access specification, that is also the responsibility of database administrator. Just like say super user of Unix environment, he has higher privileges, can do higher policy related activities. Same thing here also. Database administrator can make those policy implementation. Then say, whenever we want to create the users, so granting or revoking authorization to users. So if I want to work with a database, so I have to make a request to the database administrator to create the account for me. And at the higher level, if there is at the top level policy integrity information, integrity constraints, so integrity specification. So all these things that we are talking about, that is at the higher level policies. So that higher level integrity specification, so these are the special responsibilities of DBA. The user, when playing the role of the database administrator, can do this kind of activities. So this is a special kind of user. Now, if we look into different functional modules, already we have mentioned the major functional, most important functional module. So if we talk about the functional modules of DBMS, the most important one that we have talked about, that is the database manager. This we have mentioned. DDL compiler. DDL means data definition language. As user, we are using DDL to specify the schema. Now, just like any compiler, so obviously it will be doing some translation job. So this DDL compiler, it translates DDL statement and generates metadata. Metadata I will explain as in data about data, information about data, not the actual data. Generates metadata, which is stored into data dictionary. Data dictionary is part of database. This is very important. Now, what is say? That means if I consider for the time being, don't worry, say just take it for example. So suppose I am creating a database student where role is 3-digit integer value. Say name is like this, and say this is say unique. Say name, it is mandatory, it cannot be kept empty like this. Suppose this is, don't get confused or get perturbed by the syntax or all those things. We come across this is like that. Now see, this is a DDL statement. I want to create a database. So whenever DDL compiler will act on this, it will create certain metadata. There is no data. It will create as if that student is a database created by or owned by say user one. So in some part of the data dictionary, it will store this information. For that, I mean, how it is going to help us? Suppose I am user one. I have not allowed, I have not granted authorization to any of the users to work with this. Now see, whenever some user is trying to access this database manager, the software module, the core software module, it will go to the data dictionary. It will check who have the permissions to work with these. So if it is somebody else other than user one, will not be allowed. Suppose user one has allowed user two to retrieve data. Now user two performs that searching for a particular record of a particular student. Then again, before doing that, database manager is security enforcement. Database manager again go to the data dictionary. In the relevant part, you will see on this particular database whether user 2 can be allowed to retrieve data to search or to view the data. If it is allowed, it will be allowed. But if user 2 tries to insert data, it will check that there is no permission to insert to allow that particular user to insert data. So that will not be done. So data dictionary is very critical. See, these are metadata. It's not that we are DDL is generating some student information and that is being put into the data dictionary. No. It will, in some part, it will store that the student, this database is having roll number as an attribute, what is the type, and again constraint information. Similarly, name, etc., etc. So if I say that, show me the date of birth for a particular student, before doing that, you will check whether date of birth is it a valid attribute for that particular database. So see, it is not storing. DDL is generating this descriptive information. That whenever I will put in the data, it will be of this kind of things, or who else can work with these things. These information should be taken up by the system, by the database management system, to handle different situations. Suppose, forget about the database. You have created a file in C to store the information, your name, etc., etc. Now, suppose somebody is asking for score. Score is not part of your record. So, before carrying out lots of activities, if I have certain information that in this file for every student, such and such information are kept, then by checking those, you can say, I cannot give you the score because score is not part of the record. So these details are being stored into this data dictionary. So it is playing a major role in database management system. In order to enforce the security, in order to enforce the constraint, whenever I am adding, it will see that on roll there is a constraint, it is unique. It will consult the data dictionary. Then it will make a call to the relevant validation to check whether the new value for the roll number that is unique or not. So data dictionary is very important. So that is the DDL compiler. There is another that is DML pre-compiler. Pre-compiler, that's what we have written. See, DML that is non-procedural. Why we will be using DML? For efficient and convenient interaction with database. Otherwise, whenever I want to work with the data, we'll have to go for those procedural kind of approaches, etc., etc. So I want to get relief from that particular burden, and I want to rely on the database management system for efficient and convenient interaction with database. So as programmer, I am working with the DBMS. But see, whenever we are developing an application, in an application, procedural aspects are also required. Procedural aspects are also required. That means we need those loop, some say if-else kind of constructs, variable, constants, etc. So we need different kind of procedural constructs when we develop an application. So one way is that, okay, normally high-level languages are offering these procedural aspects. They are providing us the procedural features. So one may say that, okay, I will be working all through the high-level languages. Then you will have to take the trouble of all those activities taken care of by the database management system. Open the file, find those validation, integrity maintenance, etc., etc. Everything becomes our responsibility. Now we can combine the two. Okay, what the procedural features I will be going for these high-level languages, and to interact with the database whenever I need to retrieve data from the database, or I need to store, modify, or delete data into the database, then we will be taking the help of these DBMS statements. Then we are combining them. Then these, so we are using some high-level language plus DBMS, taking both. We are trying to develop the application programs. Then these high-level languages that in my application I refer, that is the host language. And in host language, DBMS statements are embedded. So in my application, in between the host language statements, be it your Java, be it your C, be it your Visual Basic kind of statements, inside that I am putting the DBMS statement. So it is embedded. Now see, what will happen? The host language compiler will not understand the DBMS. In this scenario, so what is the scenario? Developing an application, we want to take the advantage of both the world. For the procedural support, we need the high-level language. For smarter interaction with the database, we need the DBMS. So we have one host language. Inside the host language, we have the DBMS statements. In this situation, DBMS precompiler converts embedded DBMS statements into equivalent host language statement. So after that, the host language compiler will do the relevant obviously also library support. Those things will be required. Right? So that is the context of DBMS precompiler. Another important functional unit is query processor. Now we are writing or we are interacting through, say, SQL statements, right? So ultimately the machine will not understand those things. So this query processor, again a software module, translates user given query into a form that the system understands. Not only the translation, it also performs an optimization to convert the query into an equivalent but efficient form. A particular, see, normally the DBMS statement that is a non-procedural, ultimately some process has to be followed. Now who will go for that conversion? The execution plan. Execution plan is procedural. That role is played by the query processor. And again, that this particular activity can be done in number of ways. Which one is suitable? Suppose we'll talk about these things later also. Suppose in our student database having say billions of record, given a particular registration number, I want to search the record. Think about it, maybe a linear search. Or if I have your B plus tree kind of indexing, following that, it will storing registration number and record number, that kind of thing. Following these, I can find out what is the record number, I can directly jump to the particular record. Say, whenever we look into some particular topic in the book, it's not that from the very first page we go on searching page 1, 2, 3, 4 like that. There is a table of content or there is some index if I know certain words. So if we consult the index or the table of content, rapidly we can go to the particular page that I need. Same thing here also. There may be, in order to carry out a particular job, there may be number of ways. So what is the actual execution plan so that it becomes optimized and efficient? We are not doing anything. That role will be done by the query processor. So these are the major functional units of database management system. Again, the users, they also can be categorized in number of ways. So users, maybe the DBA, we are already aware of DBA, database administrator. There may be application programmers, the role some of you may play in the industry, that these users develops the applications using host language and embedded SQL. There may be sophisticated users who mainly they are not aware of all those host language and etc. etc. They interact through DBMS statements. They know the DBMS statements, so they will be using those as the command. Now, at the lowest level, there are native users. They are not aware of those DBMS statements and high-level language and all. Basically, the application programs, those have been developed, say they work through application program interface. So whenever we will be working as native user, some interface is there, showing the menu, clicking here, doing accordingly, we are working to that. Not aware of those SQL statements or high-level language. So these are the category of different users. Now, if we sum up the whole thing in a simple manner, so overall structure of DBMS, it looks like this. Say if we have application programmer as a user, they submit the application program that goes to the DML pre-compiler, it interacts with the query processor, will be getting application program object code. If we have a user, they work through application interface. By that, they connect with the application program object code. Now we have the database manager. Now this query processor will also interact with the database manager. Database manager will have a two-way connection with the file manager. This is obviously part of OS. Now the database in the secondary storage. we have the data files, we have the data dictionary, file manager will interact with the data dictionary, sorry, this database manager, file manager will interact with the data files. Sophisticated users submits DBMS statements, goes to query processor. DBA, mostly when playing the role of DBA, they are submitting the DDL statements, all those schema related kind of thing, that goes to DDL compiler. DDL compiler will have interaction with this data dictionary. So that is the overall. So this is our DBMS. This is the database part. Okay, some additional things will be there, say index files, those kind of things. This is a simplified kind of thing. So we have now add up the meaning of this name user, application programmer, sophisticated user, DBA. Then you know what is DDL statements, DML statements, application program, the role of the DML compiler, then the object code, you know the role of the database manager, the query processor, DML statements comes here, DBA submits DDL statements, and the database one. So this is the overall structure of the in a simplified version of the database management system. So let us stop today.